Okay, these are your notes for section 5.2. Today we're going to start looking at systems of equations, and today we're going to solve them using tables, graphs, or a graphing calculator. Good stuff. Okay, objective and what's the point? We're going to learn how to solve systems of equations, both linear and one where one of the equations is not a line. And we're going to not use algebraic solving techniques. We're going to use graphs, all graphs today. You're going to go over some of these things, like we're going to realize what it means when you have a system of equations, and we're going to estimate them by graphing before we actually find the solve. I would say every book I've ever taught of, there are 3 ways to solve it. You guys have done this before. Some of this should be review. The first way you solve systems of equations they teach you is by graphing. And the second way they teach you is by a method called substitution, and we will do that, I think, in the next section. And then the third way is elimination. It seems to me that kids prefer the elimination method, and then they go back on graphing and substitution if necessary. And I think the reason they teach it in this order is because kids tend to prefer this. And sometimes you will need these graphing and substitution methods when you're dealing with more difficult systems. But this method today is becoming more and more the favorite, I guess you could say, because now you have graphing utilities, your calculators that make this so much easier. When I used to do this, it used to be by hand. I know I'm so old. And then it wasn't fun at all because you had to have really accurate graphs. And as you guys know, most of your guys' graphs look like mine, like this. And then you're like, oh, what is that a picture of? And you can't even tell what you're dealing with. But with graphing utilities, you don't even have to worry about it. So I would say more and more people are preferring this method. Okay, what are we even talking about when we have a system of equations? Basically what we have, let's say we have a system of 2 lines. I have x plus y equals 5 and maybe negative 2x plus y equals 7. When I have 2 lines, if I was to solve one equation, first of all, can I solve this? Can I figure out what x or y needs to be? No, because this is a line. There are infinitely many solutions that make that equation true. So to say solve a line, that doesn't really mean anything. Okay? Now this is the same thing. I have another line. You can't really solve a line. But when I graph both of these, when you are solving a system of equations, if I have 2 graphs, when you're dealing with 2 lines, you can have a crossing point. And this point is special because this point makes this equation true because it's on this line. And it makes this equation true because it's on this line. So when you have a system of equations, when you're trying to solve it, you're trying to find the one point, and there could be more than one, we'll talk about that later, but that makes both equations true. If it's lines, there's just one. If you have something that's not a line, then there could be more than one. But for the most part, we're going to deal with lines and a couple of extra ones in between. So the solution is that one point that makes both equations true, and that point is on both equations and the intersection of solution sets. The other way you could think of it is if I have a table for this equation, a table for this equation, this point is going to be the one point that's on both lists, both solution set lists. Okay? Moving on. Background. Suppose you are given 2 lines and you're told to graph them. There are 3 possibilities that might happen. Okay? You could have what I talked about just 1 second ago. You could have 2 lines and they could cross. If that's the case, there's one solution. Where is that solution? Right where they intersect. The other thing that could happen is you could have parallel lines. And if this is your case, these 2 lines will never ever touch. So there's never that point that makes both equations true. So we say there is no solution. Okay, and this third thing that can happen is the equations might look different, but they could represent the same line. In which case I have one line, and then I have that other equation is a line that's laying right on top of it, or the exact same line. These 2 lines, if you think about it, touch everywhere. Okay, because of that, there are infinitely many points on a line. There are infinitely many solutions that will make that system true, because there are infinitely many points that would make both equations true at the same time. That's just lines. What if I had a line in some other function, like a parabola? Let's talk about that. I have a parabola and I have a line. What could happen? If it goes through here, it can touch twice. If I have a parabola and a line, it could, oh, that's horribly bad. Pretend that's good. It could be, do you remember what this word is that talks about this? It's called tangent. If it touches at one point, we deal with that a lot with circles. And when you're in calculus, you'll deal with it all the time. It'll be so fun and exciting. But it could touch once. It doesn't have to be there. It could have touched here and been tangent to it at any point. And the other thing you could have happen is you could have a parabola and a line that do not touch. Okay? So, and a cubic or a hyperbola, these are more options. It doesn't have to happen just twice. It could touch 3 times. A cubic, which we'll talk about later this year, oh, that's kind of bad. Kind of looks like this. There's an option here for it to even touch 3 times. 1, 2, 3. You will find that the degree, we call it the degree of the equation, will tell you how many times it can touch. But I think today you're really only going to be dealing with parabolas and a line, if that even shows up. Okay, how do we solve these? By hand, I'm going to tell you this method is pretty lame, okay? Because you have to be a super duper grapher, and I mean, no offense, I don't know many of you that are super duper graphers without your graphic calculators. I'm talking about like, we're breaking out the graph paper and we're making sure everything is good, and you're getting out your ruler and all that jazz, okay? Sometimes you could tell by the slope will line up right on top of each other, but I'm going to tell you right now, avoid graphing this by hand. You guys all have graphing utilities. I want you to use the graphing utility. These are the steps for the people with the TI 8384s. Okay, it's not hard at all. You get y by itself. Graph them both. You're good at graphing. You should see then where they cross. You might be able to estimate. You might need to adjust your window to see where or if they cross. They could be parallel. Okay? After you do that, if you can see where they cross after you adjust your window, I should write that, adjust window. You will then do second trace, and that's the calculate command, and you're looking for the intersection, okay? That's where they cross. Select each curve. The cursor will automatically jump to each line. It'll say first curve, you hit enter. It'll say second curve, you hit enter, and then it will ask you to guess. The guess, you can just hit enter again. This guess process is really if you're dealing with a more complicated one where there's multiple solutions and they want to know which one you want them to find. Okay? And you repeat that process for the number of solutions you're dealing with. And it will, right on the bottom of your screen, it will give you where they intersect. Okay? When you're looking at graphs, sometimes the text or a problem or a real life application will have a graph available for you and you're trying to see what makes both true. Make sure that you, say page 307. Make sure you do keep your equation straight. Sometimes it's hard to know which line is representing which equation, okay? If you look here, you could tell where these two lines intersect. It would be at 5 months, and it looks like at a handicap of 20. And when you are asking what they mean in real life situations, just make sure that you have this curve as the m of x, this one is the n of x, so that you remember what you're talking about, because sometimes they ask you to refer back to a certain line or whatnot. Okay, when you have a table, this is again for the TI 83 and 84 people. You plug both into Y1, Y2, second graph, that is your table icon. Then your graph is going to kind of look like this. And it'll have all these ordered pairs. And then these numbers here, you're looking for where Y1 and Y2 are the same, because that's going to tell you that's where they cross. So you could use the table. I almost always use the graph, but you could use the table. That is an option for you. Remember to check. This is really important. Your solution is going to make both equations true when you plug them in. So after you get an answer, you should really take that extra time, plug it back into each equation to make sure it's accurate. You might not do that on every homework problem, but for sure on tests and quizzes, make sure that it makes sense and that when you plug it in that you were accurate. Graphing has never been more enjoyable. Maybe for you. I have lots of fun graphing. But I'll give you your homework assignment tomorrow. All right. Thanks.